Now, before we get to that analysis, I did want to make one important note on what are called counting experiments. The kind of experiment we're doing here really is a counting experiment. After all, what we're going to do is at each of these different angular ranges, we're sitting and we're counting how many nuclei pass through there, of course in a fixed amount of time. So I really should say that this is the number that appear at a given angle in a fixed time, say delta t. Right? Because otherwise, we're not really comparing the different scatterings on an even footing. Now, if you were to sit, say, for an hour and count how many alpha particles fall in a given box, say like here we get 23. If you then the next day try to repeat the experiment is supposed to be science, it's supposed to be repeatable. You come back the next day, and in fact, you're not going to get 23. You'll get something near 23, you might get 20, you might get 26, something along those lines. So really what we're getting are these different numbers. There's a little bit of randomness always inherent in a counting experiment. And I want to just characterize some of the mathematics of that for you so that we can make proper sense out of this type of an experiment. So here I want to make a note for you on counting experiments. And I'll say random, right? Because there's definitely an element of randomness in here. Because after all, we don't know how many alpha particles are going to come out of our source in a given amount of time. So, we are going to get, and we don't know exactly, which ways each day different particles are going to be scattering. So we have to think a little bit about when there's randomness in our counting experiment. As I had just said, of course, the first thing to realize is we don't get always the same count, right? Say n is the count for a given box. We're not always going to get the same n. That's because, again, there's a certain randomness. Now, the interesting thing, though, is what do you get? So what we do get is that this n that you have is going to equal, well, there is a certain amount that you're expecting, right? It's called the expectation value of n, otherwise frequently also known as the average value of n. If you did repeat this hour-long counting for a given angle range day after day after day and built up, a list of these numbers, there's a certain average that you will eventually, come to expect. But on any given individual day, you will differ by that from some amount of discrepancy, right? So these delta n represent the fluctuations in your counting statistics. Now, there's a way to characterize these fluctuations, right? They're always going to come out, roughly, they're random, but it's kind of roughly about the same size. So we can say approximately equal to. Sometimes it's positive, of course, and sometimes it's negative. And the mathematical way we have of characterizing this amount of discrepancy we come to expect in these fluctuations is something called sigma, otherwise known as the standard deviation. And it's defined in the usual way you're used to from your course on probability or statistics. Now, the beautiful thing about this is that if we happen to know, as we do in these experiments, that if we are counting independent events, such as for us, right, we're counting these alpha particles. One alpha particle goes through the system and scatters off at some angle. The next alpha particle comes through, scatters at a different angle, right? But each of these alpha particles doesn't know what the last alpha particle did. So these are really independent events. When you're counting independent events, there's a very strict formula that tells you, in fact, what standard deviation you can expect. There's a beautiful formula for this, and it turns out to be the square root actually of the number that you are expecting. Now, this is all sort of standard probability and statistics. If this kind of thing isn't familiar to you, you will want to familiarize yourself with statistics in this course. But if this isn't familiar to you, don't worry. We have a nice set of class notes that are available in a PDF. And I always like to refer to these class notes. I like to abbreviate things on the board. I usually call those CN. And we have a set of class notes on statistics that is kind of a mini self-contained course on exactly the probability and statistics that you are going to need for our course. So I highly recommend that you review these if you're not familiar with these concepts here.